Okay, I just wanted to talk through this first example with you just to make sure you guys were on the right track. So, according to the Cremation Association of North America, which is a real thing, the number of people choosing to be cremated is increasing dramatically. The table displays the number of people choosing cremation in the US for the years 2000 to 2005. So, we're assuming they have a constant growth factor, which is the same thing as a change factor. So, let's find that 5-year growth factor and the 5-year percent change. So, we know that the change in time is 5 years, and so that means that in order to find our change factor, we just simply need to divide. So 778.25 divided by 629.362. That's going to get us 1.2362. That is my 5-year change factor. So according to this, every 5 years, the number of cremations is 1.2362 times as large. So remember, we can always take that, and if we make it a percent, that means that in 5 years, it's 123.62% of the previous. So we subtract our 100% that it already was, and we're going to get 23.62% as our 5-year percent change. So in 5 years, the number of cremations is 23.62% more than it was 5 years previous. All right, part B. So what is the 1-year growth factor and the 1-year percent change? So we have our 5-year factor. And so on the last slide, we have really just talked about how to find the smaller change factor. And so in order to do that, we don't want to go 5 years, we want 1 year. So to get our 1-year change factor, we would need to take 1.2362 to the 1/5 power, right? We only need a fifth of that 5-year factor. That's going to get us 1.0433 as our 1-year change factor. Again, just to write it out, which means that every year we have 104.33% of the previous year's number of cremations. If we subtract out our 100, we're going to get a 4.33% change for 1 year. So every 1 year, we'd say, according to that data, our sales would be 4.33% larger, not sales, sorry, cremations. All right, part C, it says write 2 equivalent functions that model the situation. So really we have a lot of options. We have our 1-year change factor that we could use, which is the 1.0433. We have our 5-year change factor that we could use, which is the 1.2362. And then we also have 2 different reference points. So let's kind of start writing out some of our options. So if we start off by using my reference point of the 0, 629, 362, and my 1-year change factor, that's going to be the most simple formula to write. So we could write C equals 629, 362 times 1.0433. Right, so we start at 629, 362, and every year we need to multiply by that factor of 1.0433. So my exponent here would just be y. So if y is 1, it's been 1 year, I multiply by 1 factor. If y is 2, it's been 2 years, multiply by 2 factors. If instead I had used my reference point of 5, 7, 78, 25, my function's going to look similar, but just kind of like with our in and out formula, it's going to kind of look like that. My reference point is not the vertical intercept. So instead of y, it's going to be y minus 5. So for every year past year 5, we would multiply by that factor of 1.0433 from the 778.25. So that's how I could write my formula with the 1-year factor, but I could also do it with the 5-year factor. So if I do that, you guys are going to love all the options, right? So we could start, let's say we start with the first reference point of the vertical intercept. So instead of here, we could instead of represent the 1.0433 as 2362 to the 1/5 all to the y. So that's still kind of saying the same thing as the first formula, but now we're representing it in terms of the 5-year factor. Like let's say I had the 5-year factor like I did in A and I was just too lazy to get my 1-year factor. I could simply represent it like this because 1.2362 to the 1/5 represents my 1-year factor. Now with rules of exponents, we're going to see, I'll make this, I don't know, just for fun. This is also going to be equivalent to 1.2362 to the y over 5, or instead of that, sometimes you could see the exponent as 1/5 y. So that's saying, hey, every time I get to 5 years, I need to multiply by a whole factor of 1.2362, or every 1 year that goes by, I would multiply by a fifth of that factor, right? Because the rules of exponents would say I multiply and all of those 3 are equivalent. All right, but then I have one more option. I could use my 5-year factor with my reference point of 5, 778.25. And so I would do C equals 778.025. And again, it doesn't matter to me which way you write it. If it makes more sense to you to start it like this, you could. But then my exponent up here would be like this. So for every year past year 5, we would multiply by a fifth of our 5-year factor from the 778.25. That's kind of how you could kind of read that. But again, you could write this equivalently. I'm going to give you your options because you'll see it often in different ways and you need to be able to understand all those different ways. This is a pretty common way that you'll see it, y minus 5 divided by 5, because again, rules of exponents say I multiply that. That's the same thing, sorry I'm running out of space here, as 1/5 y minus 5, which is the same thing as the y minus 5 over 5. So all of those are options. So really we have several different ways that we could represent this. Part C asks for 2, but hey, we'll do some overkill. And then finally, part D says, what's the expected number of cremations in 2020? So you could use any of those 6 formulas we have written, and you just simply need to input 20. And for Y, because my input is given as year since 2000, 2020 is 20 years later. So for any of them that you pick, you would just input 20 in for Y, and you should end up getting some number that's about 1469. Depending on which one you use, you might get 213 or 1469. 791. The difference there, I know that seems pretty big, but the difference really is in the rounding of the change factor. That 1.0433 is rounded. So one thing with exponentials is you really want to round as little as possible, because even like that's a 4th decimal place we rounded, but notice how different that number is. That's like 550 more people, 570 more, 80 more people. So just always be careful with rounding. But either way, so long as you're in that kind of close ballpark, either of those answers or somewhere in between with the rounding would be fine.